Hi, Omar from Episode here. In this video I'm going to show you how to set up a geometrical optimization in Cortime. Many times during the engineering process we find ourselves having to optimize a geometry. For this we will use Cortime. In this example we have a cylinder which center of mass has been displaced away from the centroid due to these extrusions. In order to solve that and put the center of mass back to its place, we have created a new extrusion which Cortime will use. The first step is to create equations. If you don't know how to set up equations in SolidWorks, you can always check out our core concept videos equations in SolidWorks. If we open the folder, we see we have 4 equations set up: height, radius, alpha, and extrude. Height represents the height of the new extrusion, radius from the center, alpha is the angle, and extrude is the thickness. The second step is to set up sensors. Once again, if you don't know how to work with sensors in SolidWorks, you can check out our concept videos. For sensors, we have select the center of mass in the 3-axis and the mass of the part. Once we have set the sensors and the equations, we can take a look at the Cortime window and start setting up the optimization. The first step is to set up the optimization variables. For it, we will use the equations that we previously created. Now it's time to set some ranges for the model. For the height, we will go from 60 to 90. For the radius, we will go from 30 to 50. From the alpha, we will go from 10 to 60. And for the extrude, we will go from 1 to 100. Now, as always, we will run the design checker to see if the file can reveal in every single part. And we see that it does, so we can continue. The next step is to set up the optimization objectives, and for it we will use the sensors. 3 centers of mass. That will set up to target. And our target will be 0 because when we created the piece, we used the origin of coordinates as our origin. So the center of the centroid of the cylinder is the origin of coordinates being 0, 0, 0. And the fourth objective will be the mass that we will try to minimize. Once we have set up the window, we can go to Optimize, Display Settings, and in here we can select which of the variables and objectives are going to be graphed. For now, let's just use the objectives and let's assign an axis to each of them so we can see them scale once the optimization is running. On the optimization setting, we'll let everything as it is by default multi-objective because we're working with several objectives. Solution space and no, because we don't know how far or close we are for the solution. The presets will let regular optimization also, because we don't know how many wrong steps we're allowed to accept. Number of sessions, we will run 1 for now, and we'll let Cortime choose the amount of iterations. In the options, we will have always show message box and display function value column ticked, because we want to see the current value of every optimization and objective and variable, and because we want to see how much time and iterations is left. And that's it. We can now start running the optimization. Once the optimization process is done, we can take a look at the results. The first thing we can do is to take a look at the actual part. we can see that it looks like the center of mass has gone back to the center of the cylinder and that the thickness has grown. If we take a look at the graph, we can see that the centers of mass, the three of them, have gone really quick down to 0 at the same time as the mass has risen up. And here we have selected the same y-axis for the three centers of mass because they are working in the same scale, and a different one for the mass. Here we can see the current values of the centers of mass, and we have 0.0, minus 0.0, and 0.0. So the optimization worked pretty well. Now we can take a look at the Analysis tab, in which we see the objectives in vertical axis connected by the iterations. In here we can select any of the iterations we want, right-click on it, and restore iteration to go back to that point. We see how the file changes. We can also zoom in and out and reduce the ranges we're working with. So in case we want to look for a certain iteration in a range that, for example, we're working towards the goal of setting the centers of mass around 0. So if we lower the ranges and then zoom in, these are all the iterations that are between 0.4 and minus 0.4. So we can click on any of them, restore iteration, and we will go really close to the optimal point. This has been a very quick summary of how to set up a geometric optimization in Cortime. I hope you enjoyed. Thank you very much.